Okay, so in this next part, what I'm going to do is go over fetal development of bones. So remember, there's two different types or two different ways that we can grow bones during the fetal period. Really, the kind of embryonic to fetal period of growth. So we first want to think about like maybe making some like a comparison chart, like what do they have in common and where are they different? And then I'll kind of go over the processes, hopefully really quickly, to show you why things are structured the way they are. Basically, how come our long bone is structured the way it is? Why do we have cartilage in the middle of it? So things we want to think about is that endochondral ossification, remember, is inside cartilage. So I'm going to go from mesoderm to hyaline cartilage. And then my hyaline cartilage is going to form my bone. In intramembranous, we have membranes. So we're going to create mesoderm first. And basically, mesoderm is going to create a type of embryonic connective tissue, which is like a membrane. So we're going to think about that as embryonic, like a connective tissue. And whoops, I'm just going to move my image over here a little bit more. And then that becomes bone. So that's one thing, okay? The other thing is endochondral is like all bones, except for most of the skull and the clavicle. So, and actually the skull and the clavicle are going to slightly be endochondral, but it's easier to just say like skull and clavicle are not endochondral for now. That means intramembranous creates the skull and the clavicle. And remember what I said in class, the brain has to have a nice area to grow and expand in. You want that to be a little bit more flexible and less rigid, and cartilage is going to be more rigid. So let's go through the process of endochondral and intramembranous ossification so we can kind of create a little bit more of a comparison chart. And see, this is the things you kind of want to do when you study a little bit. Can you make yourself a comparison chart? So for endochondral ossification, what we're going to do is we're going to start with a hyaline cartilage model. So this is going to be my hyaline cartilage model of my bone, okay? Then the first thing that I'm going to do is I'm going to take that hyaline cartilage, and on the area where I have my diaphysis, I'm going to start to build bone. So I'm going to take my hyaline cartilage model that probably has expanded just a little bit here, and I'm going to put the cartilage in each epiphysis. We're going to build those later. And maybe a little bit right here in my diaphysis. And the first thing I'm going to do is I'm going to start to lay down compact bone on the diaphysis. So remember, the reason why you want to do this is you want to make sure that your bone is going to be nice and strong, and that's by building it in the center first. So you're going to have multiple areas of ossification or growth in endochondral ossification. Then the next thing that I'm going to do here is I might use my eraser. I'll draw it out for you guys. Is the cartilage inside of the medullary cavity or inside of the diaphysis. So we have, I'm not going to color all that in. I'll color all this in. Is we're going to see that the diaphysis gets thicker, so we're going to put more compact bone on the outside. And what happens is the cartilage on the inside of the diaphysis actually starts to degrade away or starts to die. We bring in a blood vessel, and that blood vessel is going to bring in our osteoclasts, and then the osteoclasts hollow out the medullary cavity. So you can see that this is why this is called through growth, because I'm going to go through the bone and I'm going to grow first. So technically, you are going to create some of your compact bone first in this case. For long bones, yes. For other bones, when they go through endochondral ossification, it's going to be a little bit different. Okay. Then the next thing is that we're going to have, the baby's actually going to be born. And then as the baby's born, the diaphysis and the medullary cavity is formed. So that's going to be a little bit of structural support for the weight bearingness of the bone. And we're going to start endochondral ossification at each epiphysis, okay? So what's going to happen here is that we bring in another blood vessel, just like this and just like this. So secondary ossification centers. The cartilage in the center is going to start to become compact bone. So we make compact bone in the center and that, I'm sorry, spongy bone. It's late and a very long day. So we're going to make spongy bone in the center and it's going to go all the way to the outer edge. Then we're going to fill in the outer edge with compact bone next. And so what you should see is, you see how I kept my purple line on the outside? That's going to mean I have hyaline cartilage remaining on the outside of my bone where my joints are. And I'm going to have hyaline cartilage a little bit right here as well, because I probably should have made my circle a circle all the way so that you can see that. So because you're going to have multiple centers of ossification, this is going to lead to what we see in our child's long bone, where we have an epiphyseal plate that is made of hyaline cartilage between the diaphysis and the epiphyses. And is also going to lead to us having articular cartilage on the outer surface. And then it makes sure that we have a nice hollow center in our diaphysis, and we have the epiphysis that has spongy bone in the center and compact bone on the outside. So you see, that's how we're going to create our long bones. For flat bones, you still will have an epiphyseal plate. It's just that in this case, you will have multiple centers of ossification in different parts of the bone that still allow you to have hyaline cartilage at specific areas to allow for continual bone growth. So we're going to take this and we're going to learn how to grow bones in a minute. Then for membrane, what I'm going to do is membrane is going to be skull bones, and this is going to be like, you're going to create basically a membrane. So just kind of imagine I took a sagittal section of the skull and I have a membrane that's forming around my dorsal hollow nerve tube. And that is actually going to be what's going to create the skull. So in this case, we're going to have our osteoblasts that are going to be created first, and osteoblasts are going to start to lay down spongy bone at the center of our membrane here. And that spongy bone, we're going to continue to create it from the center outwards. So basically towards the periphery, the peripheral area. And as we do that, as we get to the peripheral area, you're going to see that I have still a little bit of blue, and that blue makes up my periosteum. So that's why I have a periosteum on the outside layer. And I'm just going to fill in the outermost layer here in compact bone. So I'll have compact bone and compact bone like that. So endochondral and intramembranous have some things in common. Essentially, how you create the epiphyses and intramembranous ossification will be the same, because you're going to have spongy bone, and then spongy bone is filled with compact bone. But here you have to have multiple ossification centers. In a long bone, you're going to form your diaphysis first. And then you do your epiphyses. And the epiphyses are going to grow where basically you have spongy bone and then compact. Okay, the diaphysis is just going to be compact bone. So this is why we see that adult structure. So over here, you should only have one place where you do ossification. And any place where you're kind of moving out in that bone growth area or the ossification area will remain as a membrane. This is going to give us some of the membrane that's going to stay between the bones of the skull and creates the fontanelles that we see in the skull. Here, we're going to go spongy bone. And then, of course, it becomes compact bone. So that is also going to help me make sure I create my periosteum on the outside. Okay, you will have a periosteum over here as well. It's on the outer edge of where that compact bone is. I just didn't draw it or explain it very well. So you see that there's no cartilage remaining here. So some of the things you think about is that means that your skull doesn't actually continue to grow for very long. This is why babies have a really big head, because their head has to be basically the size of the adult head, because it's not going to grow for very many years. That's why they have such big heads. So you can see there's some differences there. But this is why our flat bones will still have a periosteum on the outside, and it's going to have spongy bone in the center and compact bone on the periphery. Now, how you create the sternum is going to be a little bit different because that's endochondral ossification. So here you have multiple centers of ossification, but you don't build a diaphysis. There's a little kind of complex thing to think about, but you want to think about that is this is the reason why long bones are formed a little bit differently, because they need to be so they're long and that they have that support and the rigidity of the diaphysis. So we're going to take this, and you guys should add a couple more things to your chart. I just kind of wrote a couple of things because I don't want my video to be too long. But add some more stuff to your chart and then come and ask me questions or post it on the discussion forum as well. Next, we're going to do how bones grow after birth.